Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge number with same consecutive difference. So as the name of the question suggests that we are required to figure out with some numbers whose consecutive difference is equal. Means a number in which digits which are being there. Then when we will be checking the first and the second digit and then the second and the third digit, the difference between first, second and second, third would be equal. So that they want to say. So that's the thing which we are required to figure out. So let us read this question. Return all the non-negative integers of length n such that absolute difference between every two consecutive digits is k. The thing which I was explaining now. Note that every number in the answer must not have any leading zero. For example, 01 has one leading zero and is invalid. So the thing is that 01 and 10 means if any number is something like 010, then it is not a valid number. So that they want to represent in this line. And then it says that you may return the answer in any order. So the thing is that if we calculate, like if some number is like 181242, then we can present it like 242 and 181. So that doesn't matter that in which order we are presenting our answer. They just want our answer. And then in this first, before going to example, let us check for the constraints. So constraints are pretty much low. Means n value lies between 2 and 9 and k values lie between 0 and 9. So simply refers to that we can even go to the time complexity and space complexity of exponential. The way the constraints are being given to us. So that's the thing. So in this question we can, as you can see that it is about finding out all the possibilities of such numbers, right? So surely we can do this particular question by recursive method also. And even we can do in iterative manner also. So for that iterative manner, we are required to check out that how we can go ahead with both recursive and iterative manner. So now thing is, let's see the numbers which we are required to form. So n should be the length, means any number 1, 2, 3 length, and the difference between these two numbers should be k. So that's the thing which we are required to figure out. And then this is the thing, so we can start from 1 and then we will check that we'll add k or we'll not add k. So like this only, we'll get something here, then we'll again check plus k or minus k, and then again plus k, minus k, and then we'll check out some other digits which would be there. We are required to do all these things until we are till the level n. So that's the thing which we are required to do in this question. And like this you can see that we were able to form a particular tree, right? And this tree is basically a recursive tree only, but somehow this changed into a question of tree only, right? A binary tree, where we have option that either we will add k or we will add minus k. And that also we will check that is it a valid or not on the basis of the condition that if it comes in the range of, means n should stay in the range of this 2 and 9 and k should stay in the range of 0 and 9. So when this particular thing remains there, right, then only we are able to figure out that yes, we can add k or we can subtract k to it or not. So that's the thing which we are required to do here. So when we are able to figure out that we are going to form a tree, right? So then comes the part, then when there is a tree, then how we are going to do with that particular tree, means how we are required to figure out with the answer. So for that purpose, we will be doing tree traversal algorithm, that is either a BFS or Dfs, and this is how this question comes up as a recursive or iterative, basically level order traversal or Dfs. So this is the thing. So let me explain you this question, even the intuition more clearly, that how we are required to come up. So here's the thing. This is one of the example, the first example itself, that how we are required to go ahead for this question. So in this you can see that n is 3 in the first example and k is basically 7, right? So what we would be doing, we will be keeping account that at which level what the things are. So we will start from the level 3 and then decrease the level until we reach the level 1. And after as we reach the level 1, then we will be returning our answer. And this will be same in both BFS and Dfs approach, whatever we want to go ahead. So here I will explain you about the general approach, not even BFS, not even DFS, just general approach. So how we are required to proceed? So here the thing is that we are required to check for all the possibilities from 1 to 9. So first we will be checking from 1 and we'll add k to it, then we get 8, right? But we subtract k from it, then what we'll get? Means 1 minus 7 would be something would be minus 6, right? And that is not a valid number between the range which is being given to us. So because they require all the positive integers, that's what they were saying. So that's why we put across here that it is not possible. Then for 8 we will be checking that when after adding k, right, then what number we exactly get. Then the number we get was basically greater than 9, because 8 plus 7 would be surely, because 7 to 14, 15, that would be 15, right? And we are required to have a digit, a single digit only, right? So it now becomes 15, which is basically greater than 9, so that's why we are discarding it, right? So that's the thing which we are doing here. As we will be decreasing k from the same, and then we get 1, right? And 1 is basically less than 9 also, and in the range of 1 and 9 also, right? And basically it is positive integer also. So that's why we now got our answer as 181. Now we have done for the 1, now comes the part for 2. And like this only we will be checking for all the digits from 1 to 9. And we will be getting our answer like this manner. So this is a thing in generally we are required to do in this question. So this was general overview. So now comes the part that how we are required to convert this particular intuition to DFS or DFS approach, because both approach will work here. If we want to convert the solution into a DFS approach, then this 1, 2, 3 would be surely part of our recursive call. That we will be checking that we'll adding up our 1 plus 1 to 2, and that will be added up only at that particular moment of time when we are able to figure out that now our answer is there. Then only we'll move to the next step. And in the iterative approach, the thing would be we will be going ahead with a loop, and that loop will be filling out all this 1, 2, 3. So this is the way we will be going ahead. So just think more about the approach, that how you will implement this into the code, and for that you can pause the video also and then code and then come back. So now let me show you that how to code this particular solution. So for that, here's the code. And the time complexity and space complexity, as it is a recursive based solution, so it is exponential, and it is 2 raised to power n for the same, just because of the fact that either we will be choosing or we won't be choosing. So that's why we are having 2 options. So that's why it is basically in exponential time, 2 raised to power n, both time complexity and space complexity. So now here is the DFS approach for the same. So now comes the part that how we will do. We will be first showing our numbers from 1 to 10, the thing which we were making a tree, right? We were starting from 1 and going till 10, right? Either we can use a loop here, the way I have used here, or we can also do, means directly pass this numbers into the check, and there we will be only incrementing that number when we are able to push our answer to our answer vector. Means basically at this particular point. So like that also we can do. So that's the thing which is here. Now here comes the part for this function. So in this function, I've taken this as a private variable, private global variable, and then what I'm doing is I'm directly going ahead with this particular recursive function. Okay, let it be. So in this recursive function, what I'm doing is, here is the base case. So in this particular base case, the thing is that for this particular base case, if n equals to 1, that is it reaches the last level, right? Because in the explanation also when I showed that it is level 1, means you can see here you can see then it was level 1, right? Then I have pushed my answer. So that's the thing here only, that when it reaches n equals to 1, then I will push my answer, right? And then I will return from here. And I will return so that we can check for the next number. And that next number we will be getting from this particular loop. And now comes the next part, that was for a base case. Now here is the mean calculation. So one of them is for our, what we say that, for a positive case, and another one is for basically a negative case, because we were having 2 two scenarios, that either if it is for the positive one, you can check here. We were having two scenarios, right? Either it is for positive, that either we can add into it or either we can subtract into it, right? So that's the thing which we are doing here. So in this first, we are basically subtracting. First we are extracting the last digit from that num, and then we are subtracting from the same, and then we are checking that is it greater than equal to 0 or not, because in this also you can check that here when we were subtracting at the first, means 1 minus k, then we got something as minus 6, right? And that is not in the positive range, so that's why we have excluded that. So that's why we are keeping a check that after subtraction of the same, means after doing this, is it greater than equal to 0 or not? If it is, then we will call our recursive function and move ahead for a next step. So that's the thing which we are doing here. And what we are doing here is that here we are forming a number. This is the new number which we will be able to form, because our subtraction was basically a greater than 0, means a positive number, right? So that's why the previous number which was there, we will be directly shifting that number towards the rightmost part. That is, if 1 was there, then now it will become 1, and then we will add up basically, just discard that one case. Earlier there was 1 8, right? Then now from 8 we will be subtracting 1, right? 8 we will be subtracting 7, and then we will getting 1, right? So that's why in that scenario, here we are adding that, and now at this particular point it will become 181, and then we will be moving ahead with our k, that is same only, that is 7, and n minus 1, that is here it will become as, at that particular moment of point it was 2, right? So now it will become as 1, and it will pass to this particular, and here it will have the answer. So that is the thing which we are doing here. Else in this particular case, if k exists, basically if k is 0, right? So at that particular moment of time, even if we add something or subtract something, then it won't be valid, right? So that's why here we are keeping a check that if k is equal to 0, because you can check that k is in the range of 0 to 9. Although n is the range of 2, n is in the range of 2 to 9. Although we were starting from 1, we can also start from 2 also, but it works here, so that's why it is something like this. Now comes the part that simply refers to that this n, that would be starting from 2, and the digits which are being there, we can take them, means where is that positive word? Yeah, all they would be non-negative integers, right? So non-negative integer is 1 also, so that's why we can take. Now here we are doing the same thing the way we were doing in our negative portion. Here basically we are adding up the digit which is being there, and we will check that is it greater than 10 or not, and here it is basically less than 10 only, right? Here you can see when we were adding k to it, then it became greater than 9, right? Or you can say greater than 10. Here actually I would have put it as this one, greater than equal to 9. Not equal, yeah, I have put already, alright. It shouldn't be greater than 9. If it is, then we won't take it. That's the scenario here. So then we are checking, we are basically forming a new number and then passing k as it is, and subtracting 1 from n and passing it to our this particular recursive function. So that's how we will be doing for our Dfs approach. And then after getting the answer, because here the answer vector will be completely filled up, and then we will be returning answer. So that's the thing which we will be doing in this Dfs approach. Now comes the part for BFS approach. So basically in BFS approach, rather than using recursive calls, we will be making calls, not calls, but we will be using our queue, because in BFS for a tree we preferably use a queue. So now here our answer starts from this part. If we are taking a queue, then how we are required to take that queue? Means, is it a int only, means just storing a single digit, or we are storing with a pair? So here we are storing with a pair, which simply represent that we are storing with num and its level, right? So here the thing was, our level was n minus 1, not the k, but n minus 1, and this was our number in our DFS approach. But in our DFS approach, we are storing like this. num and then level. And then here what we are doing is, now we are directly checking for that from 1 to 10, whatever numbers are being there, we will be directly pushing the same into our queue. Here we are, because this is at our level 1. Here we are doing things from this manner. We starting from the 1 level, means our num will start from single digits and our level will be something 1. We are starting from this, means starting from the start most level. Earlier we were doing from 3 to 1. Now we are going to 1, 2, 3. So that's the thing which we are doing here. Now comes the next part, just the result which we can even declare above. And now comes the part, this whole BFS approach. Now in this particular, we are taking, because our queue is basically in the pair form, so as per the newer C++ convention, means a newer version of C++, we can take the pairs which are there, means first and the second which was there in the pair as like this also, as we can directly do the way we used to do earlier, like q.front.first, like that also we can do. But yeah, if now there is something good, then like that only also we can use. So here we are putting the whatever is there in the front in this particular, and then when we are popping out as usual, which we do in our BFS, then we are checking that if a level becomes equals to n, right, then we will be directly pushing our answer to our result. So that's the thing which we are doing here. And then here we are figuring out with the digit, because each digit which is at the last most, means if we go ahead with this one, means 1, 8. So this will be digit on which we will do calculation plus k or minus k. So that's the thing which we are figuring out here. So now comes the next part. Here we are getting answer by adding up, and here we are getting answer by subtracting. Because we have two options, either we will subtract or either we will add. So here we are checking for adding. There was a constraint that it shouldn't go a bit, means more than 10. So that's the thing which we are checking here, right? And then we are also checking for our levels also, that level should also be at that particular moment only. It should till n or it should be less than n, because here we are not making any recursive calls. So that's why at each if condition also we are required to check that at what level it is. Then here we are forming the new numbers, and then we are directly pushing that new number to our queue. So that's the thing which we are doing here with our level. And the same we are going ahead when we are basically subtracting, and in that we are also keeping a check that our k should be greater than 0, and then the whole thing is as it is the way we were doing here. And then at the end we will be returning our result when our queue is basically filled completely. So this was all for this particular question, and if you have any doubt you could directly comment that down, and if you like this explanation you could like, subscribe and share. So this was all. Thank you.